Alright, hello everyone. Welcome back to another Leetcode problem, which is group anagrams. This is a medium problem. What it's basically, you are given a list of strings. What you have to find is what are the different anagram strings out there in that string. What it means is you have been given the strings. Now if you are being tasked to what is the equivalent anagram of eat, for example, if you see eat and tea, these are basically made of same set of characters, so these two are anagrams. And then you also have eight, so these three are basically anagrams of each other. So you have to combine these three in one, and then you have to repeat that same for all these and group all the anagrams together. So that's the question. So before we start brainstorming, as the brute force approach for this one is obviously what you can do is you can sort each of the string within the list, and then you compare if there is an equivalent string available within in that list. So you can call that, okay, that index, and then you maintain a separate list of it, and then you basically say, okay, this at this index and this index, those two words are anagram of each other, or three words are anagram of each other, and then you basically put it in an array group of those together, and then do that. So that's one approach, but obviously not an optimized one. So what we will be doing is we have to get to an optimized approach. What I mean is so the if you look at that time complexity for that one would be around O of at least if not O of n square, you can at least get it by n log n, because it involves sorting, or n log n. So if I and it would be if I don't have to go that route of sorting, and you will be sorting, as many characters as this string has. Suppose it's n characters, and then you are sorting, let's say average length is k of each string within the list. Then your total time complexity will be n into k log k, right? So now let's look for an optimized approach. What we can do is if I somehow what can I do? So I'm just thinking of an optimized approach for this one. So if I do it by counting each character and making a a storing it in some form. Okay, this has like 1e, 1a, and 1t, and then I go ahead and count another one. Okay, this also has 1t, 1e, and 1a. Technically these two are same in terms of it has similar words, so I can then compare it and say, okay, it basically has the same. But the question would be, how can I really keep the order? Because here the E is coming first and here the T is coming first. Obviously one approach is do a hash map of put this whole thing in a dictionary of each one, 1E, 1A, and 1T, 1E, 1A, 1T, and then you compare those which are the you compare the hash maps of every single one. Okay, which one is similar that way, but that will also involve a lot of comparisons if you start maintaining multiple hashes. So what we have to do is build some sort of a key where I can keep the order same for all, maybe in an alphabetical order. So if I have to go and count, okay, how many A's are in there, how many B's are, how many C, how many E, how many Z's are there. So in that way, if I can go and build a key based off that, and then if for that specific key that's going to be unique for every single word, and it's going to be the same if the number of characters are same. Number of, I mean, these characters are same, then it's going to be this. It's going to turn me the same key. Then I can just build that hash map. So what I'm talking about, I can probably draw it. So this is how it's going to look like. So you will kind of like, I will be maintaining a map where my key values will be, where I will have 1A, if I go in alphabetical order, 1A, 1, let's say 1E and 1T. And this is going to be the same, and then I am going to maintain a list of what are the values for the same one. Then it will be here. I can put like, okay, I have my first value as eat, and my cursor is a little bit the second value is t. Then I can start putting in the values for this and start appending it. Okay, this will be my third value by appending that newer value as I get for the same key. So that way I can iterate over and then return the values for that. So that's the approach. And now how about how we're gonna build this one? It's going to be what we can do is initialize and because this is a key and this needs to be a immutable field. You cannot really keep a list or mutable key. So for that, what I can do is I can initialize this as a one way is I can initialize this as a 26 character list. Each and every element of the list is initialized to 0, and then every time I get a value, I will put its whatever that character value will be. So let's say A will be 0, B will be 1, and how can I get that? By getting its actual ASCII value and subtracting with the ASCII value of A from that. So ASCII value of A is 97, and suppose you got a B, that's ASCII value is 98, and then you subtract it, you get the value 1, and then what you do is your A will be 0 and your B will be 1 in that place. And then you will build up this array, and then once you have it, you basically try to make it an immutable by either make it a tuple or a string, so that you get a fixed value, and then you put that as a key, which is going to remain same across all the similar set of character strings. So yeah, that's the logic. So now let's get into the coding part of this one. So if I start with, so now first thing first, I will just define a a variable, or let's say a key. Let's define first a map where we will be putting all these, I'll just call it as a counter, and then my first would be, I can start going over the list, then define as we go over, let's say, I don't know, I'll call that as a word, because I can call a different iterator for every single character in the word, and then C inside a word. So I can now start reading each and every word, and once I read a word, what I have to do is now I have to build a as I described, I'll be building that string, the immutable key for that every word. So for that, I'll just initialize the key as empty array which is of length, because right now it's assuming that it's all lowercase characters. So let's say it's all 26 character empty array, and then what I will do here is every time I have to, for every character, I will get the ASCII value of it, subtract with the ASCII value of A from that, and that will basically return me the actual value. And what I'm gonna do is use this value and go into the array of that index and initialize it to whatever value it has, just add 1 to that from there. So that's basically, if it already has a value, then it will be incrementing. If it doesn't, it will be just 1. So once I get all these ones, I'll be at the end of this word, I'll be getting the result, the key modified according to the every single word. So I will just use that as a the key array, and I will convert into a tuple. So I can put that into the map, in my counter map, and I will use that, whatever my counter map, and then I will append it with whatever words I have, whatever word I have. Here I can take a default dictionary, which is also what basically that does is it initializes everything as a empty list, so you don't have to worry about whether that exists or not. Default dictionary of lists, which can be imported from collections. So that, and then once I get this all built up, so what we'll eventually have the final counter map build, and now I just have to return all the values, which is nothing but the resultant output. So I can return it by list of counter, I would say counter dot. So that should get me done. So let's execute the code. Hopefully doesn't have any issues. Okay, there's, what is that? Default dictionary. Okay, it's just this is one of the things that cool. So we have got all the different sets of characters. So that's about this problem. Thank you everyone for watching, and we'll see you in the next one.